In this section, we will talk about exponents, square roots, and the order of operations. Here's the definition. For any counting number n, b to the nth power equals to b times b times b times b n times. In other words, b to the nth power is b multiplied by itself n number of times. We refer to b to the n at the nth power of b. So n, this is called the power or the exponent, and b, this is called the base. We got the base b raised to the nth power. Two powers to b have specific names. B to the second power is the square of b, or b squared. B to the third power as a cube of b, or b cubed. One thing we have to be careful about is whether the base is in a parentheses or it's not in a parentheses. For example, if we have negative 3 to the fourth power, the base is 3, not negative 3. So the 4, it's only for the base 3. The negative is outside of that exponent. So negative 3 to the fourth power is negative 3 to the fourth. So there's only one negative and 4 3s, so the answer is negative 81. Once again, if you have negative 3 to the fourth power, the 4 is exponent only for the 3, not for the negative. So it's negative 3 times 3 times 3 times 3, which is negative 81. However, if the base is in a parentheses, like here, we got parentheses negative 3 to the fourth power, then this entire parentheses gets multiplied 4 times. So it's negative 3 times negative 3 times negative 3 times negative 3, which is positive 81. Here are some examples. 5 to the fourth power is 5 times 5 times 5 times 5. Negative 3 to the second power, notice that 3 is not in a parentheses, so it's negative 3 times 3. However, if you have parentheses negative 3 to the second power, this will be negative 3 times negative 3. 4/5 to the third power, when you have a fraction, we separately take the numerator to the third power and the denominator to the third power. So 5 times 5 times 5 times 5, this is 625. Negative, only one negative, 3 times 3 is negative 9. And once again, this is because the negative is not in a parentheses. So the square is only given to the 3. Parentheses negative 3 squared is negative 3 times negative 3, which is positive 9. 4 cubed is 64. 4 times 4 times 4. 5 cubed is 125. 5 times 5 times 5. So here the answer is 64 over 125. For any non-zero b, b to the 0 power is equal to 1. In other words, we can have 5 to the 0 power, it equals to 1. We can have 10 to the 0 power, it equals to 1. Let's talk about square roots. If a is a non-negative number, this is important. A cannot be negative. Then the square root of a is a non-negative number we square to get a. We call the square root of a the principal square root of a. Here's an example of that. Oh, and some definitions. The root is called the radical sign, and whatever's inside this thing, this is called the radical. Let's find the square roots. Square root of 49. So we want to think about which number multiplied by itself will give you 49. Since 7 times 7 is 49, the square root of 49 is equal to 7. Now, look at the definition here. If a is a non-negative number, we cannot square root a negative. If you put square root of negative 49 in a calculator, you'll get an error. So here, this is not a real number. So we can't calculate the square root of for negative 49 in the real system. So any square root that's a negative will not be a real number. However, If the negative is outside the square root, that's completely fine. Then we have a negative outside the square root. 49 is 7 times 7, so the square root of 49 is 7. There's still a negative on the outside, so the answer is going to be negative 7. Now we have negative square root of negative 49. In multiplication, we can say negative times a negative is a positive. However, square root is not the same thing as multiplication. In square roots, this has to be simplified first. But we cannot simplify the square root of negative 49. Therefore, this is not a real number. So any square root that's a negative is not a real number. And for positive square roots, feel free to use your calculator. For example, if we have square root of 19, nothing times itself will give you 19. So the only way to evaluate this is using a calculator. Now here are a couple of things we have to know. If a square root is not a perfect square, perfect squares are things like 4, which is 2 times 2, or 9, which is 3 times 3, or 16, which is 4 times 4. So if a number is not a perfect square, then it'll always be an irrational number. Remember, we talked about irrational numbers. These are numbers that have decimals that don't repeat and don't end. Any square root that's not a perfect square will always be irrational. So square root of 19 will be an irrational number. If you put square root of 19 in a calculator, the answer is approximately 4.36. And test that out on a calculator just to make sure that you're able to do it. So square root of 49 is approximately 4.36. And notice we don't put equal to, because equal to means that this is exactly 4.36. We put this symbol, which means it is approximately 4.36. But when we're rounding to the second decimal place, we have to look at the number after the 6. So if you take the square root of 19 on a calculator, if you want to round to the second decimal place, that means we have to take at least 3 decimals. So the actual answer in a calculator will be this. It'll be 4.3588. Okay, here's how we deal with rounding. If we're rounding to the second decimal place, we underline the second decimal place. That's what we're rounding to. But we look at the number after the second decimal place. If the number after the second decimal place is 5 or higher, we round up. If it's 4 or lower, we round down, or we keep it the same. So because a number after the 5 is 5 or higher, we round up to 4.36. If you put square root of 169 in a calculator, you will get the answer equal to 13. And the reason for that is because 13 times 13 is 169. So the square root of 169 is equal to 13. But again, for the square root problems, just use a calculator. Order of operations. First perform operations within parentheses. Parentheses comes first. Then perform exponents. Then perform multiplication and division, going from left to right. This is important. So anytime you do multiplication division, always go left to right. Lastly, perform addition and subtraction, going again from left to right. So in order of operations, always go left to right, and this makes up PEMDAS. Here's an example. 9 minus 8 divided by 4. So what I recommend, until you can do this naturally, write down PEMDAS for each problem and go through each step. Do we have any parentheses? We don't, so we cross it out. Do we have any exponents? We don't, so we cross it out. Do we have any multiplication and division? We do. We have 8 divided by 4. This has to be done first. Addition and subtraction is after multiplication and division, so we cannot subtract 9 minus 8, since subtraction comes after multiplication and division. So we would first divide 8 divided by 4. 8 divided by 4 is 2. This gives us 9 minus 2. Remember, we can never add or subtract until all the multiplication or division is performed. Then 9 minus 2, this is equal to 7. Okay, so go left to right. No parentheses, no exponents. We do have multiplication and division. We have division in this case, so we divide first, and addition and subtraction is at the very end. Let's take the second problem and write PEMDAS on the side. Parentheses. We do have a parentheses, 6 minus 4. The key to order of operations is writing each step And I know it's going to be time consuming and a little tedious, but we just have to write everything out except for the operation you're performing. So in this case, we're simplifying the parentheses. So we keep the 10 divided by 5 plus everything the same except for the parentheses. This will give us 2. And that's step number 1. Once a parentheses is simplified, we cross that out. Do we have any exponents? We don't, so we cross that out. Then we do multiplication and division going from left to right. So 10 divided by 5, that gives you 2. We're not going to do any addition to the last step. So the addition sign, we're going to keep the same. 2 times 5, that's multiplication, so we perform that. We're doing multiplication and division. 2 times 5 is 10. And I'm sorry, 10 divided by 5 should be 2, not 5. And 2 plus 10, this will give us 12. Okay, so first do the parentheses. That gives us 2. We have no exponents. Going left to right, 10 divided by 5 will give us 2. 2 times 5 will give you 10. And then lastly, we do addition and subtraction. 2 plus 10 will give you 12. Here are some more problems. Okay, let's write down PEMDAS and go through each step. Do we have a parentheses? We do, but there's nothing to simplify, so I'm going to cross that out. Do we have an exponent? We do. Now notice that whatever step we're on, that is the only operation we perform. So if I'm on the exponent step, I don't do any multiplication, any addition, any subtraction. I only do the exponent. So we have 3 plus 2 cubed, that's 2 times 2 times 2. 2 times 2 is 4, 4 times 2 is 8, so 2 cubed is 8. And again, I'm not on the multiplication step, so I don't do any multiplication or division. I only do the exponent, only one operation at a time. Okay, once I do the exponent, that's simplified. Now I can go to multiplication and division. So leave everything else the same except for the multiplication or division. In this case, 4 times 5 will give you 20. And then finally at the end, then we add. Remember, you don't add anything until the last step, unless it's in a parentheses. So we have 3 plus 8 is 11. 11 plus 20 is 31. And I can cross that out. Lastly, once again, let's write down our PEMDAS. Let's start with the parentheses. We have a parentheses here. So I'm not going to do anything else besides that parentheses. 2 minus 6, that's negative 4, to the third power, minus 8 divided by negative 2. Notice I'm not doing any exponents or multiplication, division, or addition, subtraction, only the parentheses. Cross that out. Next is my exponent. We have one exponent, negative 4 to the third power. So negative 4 to the third power will be negative 4 times negative 4 times negative 4. Notice the negative gets multiplied each time because the negative is in a parentheses. So negative 4 times negative 4 is 16, and 16 times negative 4 is negative 64. So negative 4 cubed is negative 64. And then you have minus 8 divided by negative 2, which is negative 4. Doing this is incorrect because I'm not on the multiplication or division step. I'm only on the exponent step. So I wanted to show you guys that if you do this, this will be incorrect because we're not on the multiplication and division step. So let's erase that and let's keep it the way it is, which is 8 divided by negative 2. Now we're on the multiplication and division step. So let's go left to right. 7, there's no multiplication there. Negative 64, no multiplication there. We do have 8 divided by negative 2, that's negative 4. Now we can do the division step. Finally, we do addition and subtraction, going left to right. 7 plus negative 64, that will be negative 57. A negative and a negative, this is multiplication. Negative and a negative back to back becomes positive. This becomes positive 4, and negative 57 plus 4, this will give you negative 53. Okay, we will see more examples in class. In the meantime, if you have any questions, please think of them and be prepared to ask them in class.